Here we are at checkpoint number 8, very similar to example 6 in our note-taking guide because it's about volume. So what if a box in the shape of a rectangular prism has a volume of 180 cubic feet? The box has a length of x feet, a width of the quantity x plus 9 feet, and a height of the quantity x minus 4 feet. Find the dimensions of the box. So we know the volume of a rectangular prism is length times width times height. I'm going to plug in what I have from the problem. The volume's 180, the length is x, the width is x plus 9, and the height is the quantity x minus 4. So I've got everything I have from the problem. Now I got to start working out how to get this into a polynomial form set equal to 0 so I can factor and solve for x. So first I'm going to multiply my dimensions. So x times x plus 9, I'm going to leave everything else as is, would be x squared plus 9x. That still needs to be multiplied by the quantity x minus 4. Now I've got two binomials that I can multiply by each other. I'm going to use FOIL to do that. So first, x squared times x is x cubed. Outside, x squared times negative 4 4x squared. Inside, 9x times x, so 9x squared. And last, 9x times negative 4 would be negative 36x. Looks like I have some like terms in the middle here that I can combine. Negative 4x squared plus 9x squared. So I'm going to do that on my next line. 180 would be equal to x cubed plus 5x squared plus negative 36x. I can subtract 180 from both sides. So that's going to leave me with 0 equals x cubed plus 5x squared plus negative 36x plus negative 180. So now I'm ready to factor and solve. Now I've got 4 terms this time in my polynomial, just like I did in example 6. So I'm going to have to group them. And as I look at the order they're already in, I see these have a common factor, and so do these. So I'm just going to go ahead and leave them in the same order and factor them this way. Let's see, I can factor out x squared from both of these. So I'm going to factor out x squared, which leaves x plus 5 here. Plus, now I'm going to factor out, it looks like I could factor out negative 36. I'm going to try that. If I factor out negative 36, I'm left with x plus 5. So that worked out well. I've got a common factor within each of my terms here. So I'm going to factor that. So now it looks like it factors out to x squared minus 36 times the quantity x plus 5. And here again, I might think I'm done, but if I look at what I have right now, this again is the difference of 2 squares. So I'm going to factor that. That would factor out to the sum and difference pattern. So this is going to be x plus 6, x minus 6. How did I know that was the difference of 2 squares? Make sure you're looking for perfect squares here. Perfect squares. Anytime you see perfect squares in a binomial, you're going to have the difference of 2 squares. In a trinomial, you're going to have a perfect square trinomial that you need to factor. So my final equation has 3 factors, which means x could have 3 values. X plus 6 could equal 0, x minus 6 could equal 0, or x plus 5 could equal 0. So very similar to what happened in example 6. So here x would equal negative 6, here x would equal positive 6, here x would equal negative 5. So this time we have 2 negative values for x, which means we don't have to think too hard. X is the length this time, I believe. Yep. We can't have a length that's negative, so that eliminates both of these, which means x has to be 6. We have no other choices. So if the length, which was x, is 6, let's figure out our width and our height. The width was x plus 9, so my width will be 6 plus 9, which is 15. I believe we're measuring in feet. My height was x minus 4. So my height, x minus 4. So we're doing 6 minus 4, so 2 feet for the height. So we have all our dimensions, and we have finished checkpoint number 8.